What ho, welcome back to another exciting adventure of the Plain Truth 2.0. I'm your host, Travel Mateus. I am just going to be reading this 35-page article by Andrew Thomas Young. And I've already skipped past the part where I was going to highlight something. But anyway, I'm just kind of rambling right now to wake up a bit. However, there is this one important caveat in his introduction that is a confirmation. When was this written? 23. So this is just a 2-year-old article, but this is what I have been saying, right? It's the condition of the medium through which you are looking, which is the limitation of your vision. Every single time. As long as there is not anything higher between you and another target, that's physical obstruction, right? As long as you have a vast open wilderness of terrestrial or aquatic distance, the only thing between you and the target is the air. So the very first sentence says atmospheric refraction displaces the objects, okay? As the displacements, as the displacement of the objects depends upon the structure of the intervening air. So he is confirming once again something that I was able, or any of you would be able to deduce by watching these events. There is no need ever to appeal to a curved surface. Ever. Zero. None. Why? First of all, appealing to the curved surface of the Earth, and there's actually, was there another, I'm trying to think of where I saw this real quick. Was it here? Yeah. This is just a random, I just found this citation in the paper that I'm reading right now, and I looked up this, I don't think that this is the actual citation because the page numbers don't match, so, however, there was one, I don't know where to go, there was one sentence that I just happened to look at, which, yeah, here it is. The curved surface of the sea. The curved surface of the sea. That's an assumption because there's no physical measurement of the surface of the sea being curved. Zero. This is all an optical effect of what you see. So when you see the limitation of your vision, what causes that? The curved surface of the sea, because once it curves, everything beyond that apex is now out of your vision. There is a, for those of you who are watching, this is a special treat for you. I didn't put this in the title because trolls are going to just hound this. And I mean, if I lose contact with Andrew Thomas Young, then so be it, because the back and forth that we have had in the past are evidence to me that he is not interested in citizen science. And he has brought up numerous times the criticism that, well, because you're not willing to talk about the trigonometric figures of quadratic equations, I'm not going to talk to you about these things. He brought it up again in this, but he hasn't shut that door. But he brought it up. He's like, what's your level of math again? Like, how well are you able to speak English again? Here's my point. How is what your equations say any different than what I'm saying? Right? Because I see what I say what I see. So the equations that he puts out should say what I see too, right? We should say the same thing, but they don't. Why? Because there's an underlying assumption that requires the equation to include curved surfaces to correct for, and like, you can do that math, right? Anyway, I showed you in the previous video that I had asked him a question, right? And then I sent him inserts of my captures with what I think he's trying to communicate. Listen to what he says. Wow, you're taking my experiments. I'd like to see that citation on his site where he says, fair warning, everything below the title is purely theoretical and has no basis in reality. Because it's an experiment thus far, right? When you're experimenting with something, you don't have answers. This is an experimentation, like it has to be tested. You get this? Listen to what this guy says to me. You are taking my experiments in Mirage simulation too seriously. How the fuck else am I supposed to take this? This is a scientific field by a PhD who's presenting simulations to explain how and why we see what we see. And there are plenty of times when I've done this in the past where I point out to say, look, you see what he's saying right now? He's making things up to construct the model. Here's what he continues to say. I was already aware a few years ago that the simulations are not realistic. Huh? I mean, I know that because I never see a triangle out in nature. I don't see this, right? Not only that, but the target is pristine. But if you're looking over the ocean 6 miles, this target is not going to be acute. It is not going to be crisp and linear. It is going to be diffused. The edges are going to diffuse into the air where you can't see the air, and then there's the target, and then it's so like none of this is realistic. And yet this is where people go to prove and go, oh look, there's the model, there's where the Earth curves. You see this part right here? This is proof that the Earth is curving because look, this is how much you can only see of the target. But there's so much that goes on behind this, because you'll see in his, if you just look at the floor right here, you'll see that in different situations, like see here, it's not the same floor. You see that? This is not the same. So the depiction of the floor is, why is that? I mean, this is just a rendering of a diagram. So this is not reality. However, he is depicting the fact that the condition of the medium, the intervening space between you and the target, affects the way the floor looks too. This isn't just a different day with wind and whatever, but this is the same distance every single time, right? Because that's the idea. If you postulate that the horizon is roughly 5 kilometers away, and that's the reason why you can't see this target, what does it mean when the horizon is closer to you? Oh, well, it's still curved. But you're missing the point, because the common denominator in everything, which means you can erase the one thing that's the anomaly between the two models, is that we are looking at everything above the surface of the Earth. This is all happening above the surface of the Earth. And as B. Flat pointed out in his 2 or 3 videos ago, that the plane of reference, if you're standing on a ball, doesn't matter if it's a ball, because everything that you visualize in space is above the surface. So then you have to create an environment that gives you orientation, and that environment is always linear. It's always linear. There's no need ever to talk about the Earth below your feet when you're making observations, unless out there in the distance you see a higher point of elevation, perhaps. Like, oh, what's that? Didn't see that yesterday. What's going on way out there? I can't tell because I'm over here. So I need a team of people, or someone to stay here while I go out and find out what that mountain is, or whatever that is. Right? This is what happens. I was going to just be reading, and now I'm just... Anyway, there's so many times where in reading these things, I see things that are confirmations of what I've been able to deduce with my own naked eye through a camera. And then there's just a lot of stuff that's not relevant to these discussions. Anyway, I got down here to... I think right here, I was reading about Ibn Saul. All right. All right, well, we'll just go to Thomas Harriot. In the 1950s, it was noticed that Thomas Harriot had actually found and used the sign law around the edge. Now, notice that this relations among atmospheric structure, refraction, and extinction. So this is having to do because Andrew Thomas Young is a astrophysicist, which means he deals with less of the terrestrial and more of the celestial. Right? You're looking up into the sky and you're measuring distances and angles and all this kind of stuff for the stars. But it does crisscross over into the terrestrial refraction, and he's mentioned it a couple of times here, but we'll just see what happens. I haven't read this paper before, and I'm only on page 5. Harriot discovered that his discovery was entirely empirical. That's good. And just required more accurate measurements than earlier works had made. These observations were made and used by Harriot in the next few years. He had certainly had the sign law by sign law, blah, blah, blah. Snell's work is better documented. His outline for a manuscript on refraction, thought long to be lost, was discovered in 1935. What was found is clearly only an outline. Snell, see, like, this is just background. This is irrelevant. Like, I don't need this information. I don't need this information. Homogeneous model. According to Ptolemy, astronomical refraction occurs at the surface that separates the air from the ether. That's an interesting distinction. Air from the ether. This supposed surface was assumed to be real until the 18th century, and then there's no citation for this. Why was it then determined not to be real? This supposed surface. Now again, this goes back to the supposed surface. Yeah. Astronomical refraction occurs at the surface that separates. So this is boundary layer meteorology, right? You have boundary layers out. As you look out, it's supposed to say that we're told that the lapse rate of the air, if you're standing on the ground and you're looking out over the distance, if you do a zenith angle 90 degrees from your position and you go up 6.5 kilometers, which is roughly like 3 miles, right? That's the area of uniformity. Right, the lapse rate hasn't changed. The lapse rate of change is typically 6.5 kilometers. So that means in that space, as you're looking out, there's uniformity. As far as I'm understanding it, I could be corrected. But regardless, the point at which that lapse rate begins to change, that is a surface. And that's exactly what his paper against Monge was about. Look right here. Listen to this. This is the end of the article that I was reading the other day. Did Monge really explain inferior mirages? Here's his final parting words. The contrast between the simplicity of Monge's internal reflection, which is a more simple explanation, which is the one that I think is the true one. So when I was reading Monge and what he was describing, I'm like, that's what I think. And this whole paper was just, it's just wrong. It's just wrong. There's no scientific empirical argumentation against It's just, look at this guy who said he was wrong. Look at this guy who said he was wrong. Look at this guy. And they were all going, that can't happen. That can't happen. That doesn't happen. The contrast between the simplicity of internal reflection and the actual complexity of mirages is striking. His model is much more simple, but ours has a lot more confusion and equations in it, and that's better. Perhaps the saying that there is always a well-known solution to every problem. Neat, plausible, and wrong. This is just a hand-wave dismissal. This paper is just a hand-wave dismissal because of a theoretical concept. Our theoretical concept doesn't match your empirical observation. So you're wrong. Perhaps that saying accounts for the persistence of Monge's story. Poor guy, he's only known in the real world of this discussion for introducing the popular idea of the word mirage. That's all he's done. And it's just a tragic set of circumstances. For everyone out there listening to the sultry sound of my voice, if you think science is interested in changing, you got another thing coming. Absolutely, you have another thing coming. I've been at this for 7 years, and no one wants to be corrected. No one wants to be corrected. I even had another PhD on my channel, if you've seen those videos, where this PhD, after having conversations with me, in every single one of these interviews that I had with him, every single one, he affirmed my scientific research in terms of the field studies that I was doing. And when I explained to him my breakdown against Andrew Thomas Young, he understood the ramifications. He said, what about, because I was explaining what we were seeing without reference to the curvature of the earth. And he said, after hearing my explanation and saying this is what's going on here, he's like, well, what about the curve? I'm like, yeah, it doesn't need to, I didn't say this at the time, but yeah, there is no curve. There's no, if you say to me, what about the curve? And I'm like, oh, I forgot to bring that in. Like, how would anything change? Can you riddle me that? How would anything change? If I can explain what's happening out there to the best of my ability, and you look and see, and you like, what he says makes sense, what he says makes sense, and there's no reference to the curvature of the earth, the question is, why was it ever brought into the discussion? And if you now bring it in, how is that going to change what that looks like? It's not. The appearance of the horizon is the same in both models. It's just that in mine, the cause exclusively is the condition of the medium through which you were looking. And the cause exclusively for the other model is the curvature of the earth. The limit of your vision when you can't see the water anymore, that's where the earth is curving. All right. Oh, the other part of that going over to Monge was that he also, as I do, describes the surface upon which the mirage is happening out in the distance is in the air, and that at that angle of light is coming from, and it becomes a surface upon which the, it's like, how could I think about this in a sense? Do you know how when, it's almost like, I don't know how to say this. It's almost like those optical effects where, oh, that's it. Like if you, how do they do that? I can't even find it. I can't even think about it. But it's those angles of the words, right? If you look at it straight on, it just looks like squiggly lines. But then if you lower it, and then you can see those things at that angle, it reads as a sentence, right? Long ago and far away, or whatever, and it goes into the distance. That's the angle of resolution for the image of the reflection that you're looking at in the air. It's in the air. It's not on the surface of the water. The surface of the water is not the surface upon which the mirage is taking place. And so we all know, as far as I know, that reflections have to have a surface. So what's the surface? It's the air condensed at that angle. And then if you move up, it disappears. Why? Because you're changing. It's like just changing the, like, can you see the words now? Nope, nope. Can you see him now? Oh, I can see him now. Nope, can't see him. Oh, can see him. All right. This is what happens. I'm not reading. Below this surface, the air was supposed to be uniform, incapable of producing any refraction, except perhaps for those obscure vapors near the horizon. Those pesky little vapors. All right. In the late 17th century, Giovanni Domenico Cassini began working with Count Malvasia, a rich, aristocratic elite fuck with a private observatory. Look at this shit, man. Look at this. Yeah, thanks. Wish I could be Cassini. A rich benefactor. Yes. Make it happen. Cassini's job was to help the Count produce improved ephemerides. Ephemerides. What the hell is that? Improved ephemerides. Amphetamines? In astronomy and celestial navigation, an ephemeris, ephemeris, is a book. Improved ephemerises. He soon found that better observations were needed and was able to get an enormous heliometer installed at the huge Basilica of San Petronio, the largest building in Bologna. This instrument consisted of... Okay, I don't want to know about this. This is all astronomical, right? But he sends me this... I got this article from Andrew Thomas Young himself. He sent it to me. Because he has this quote. Oh, this is what it was. He has this quote because... He says, the most unrealistic error in my mirage simulations, which were experiments really, is because they were based on the standard atmosphere. And yet this guy leaves this stuff up. He doesn't explain any of this here. Like when you look this up, if you're like, oh, I wonder what atmospheric refraction is, and this comes up, there's no parenthesis at the beginning saying, be warned, everything below this is complete... trying to not use the word theoretical because theoretical anymore doesn't mean anything. It's just like everything below this has yet to be confirmed. How about that? All of this information here is completely hypothetical and has yet to be confirmed because it's based on a standard atmosphere that does not exist. And that's what this paper has in it. At some point he says, I'm not even paying attention if anybody's here. Yeah, I'm not looking with my shiny eyes at the chat. Sorry about that. Whatever. If you're still here in the chat, say hi. Chilster Deluxe, what's going on? India, what's going on? Lex, hey, hey, hey. Too low audio. Again? Oh my goodness, why? I don't know if that's you, because this hasn't moved at all. I don't know what to tell you. So you can't hear music? This is so weird because nothing's changed since yesterday. Alright, anyway. This might be an opportunity for me to check the... I don't know, Lex. I just checked, and my volume that I just checked is pretty decent. So sounds like you guys might not be here because nobody's responding to my question if anybody's in the chat. Okay. The model has two parameters: the refractive index of air and the height of the uniform atmosphere. Yeah, all of this stuff. I think maybe this, again, this is just all atmospheric, or I mean, astronomical refraction. So this isn't going to be great. So I think he's just giving this to me. So he says, I published a little more detail about this in section 13 of my paper. Section 13. Watch, I'll give you an example, right? I'll give you an example. Listen. Was about. Look right here. Listen to this. This is the end of the article that I was reading the other... I mean, this is on my phone with a full volume. I can hear myself clearly, so I apologize, Lex. I'm not sure what's happening for you, bro. All right, so this is section 4. We need to get to section 13. Real atmospheric structure. Alright, so 14, that's 13 still. It says it's standard atmosphere. You say 13 or 14? 13, here it is. The ISO standard atmosphere that has been widely used to calculate modern refraction and air mass tables is essentially the same as the 1976 version, which was the same as the 1966 version. Indeed, the troposphere and lower stratosphere tables can be traced back to the very first U.S. standard atmosphere that was introduced in the 1950s. All of these model atmospheres start at 15 degrees Celsius and have exactly the same tropospheric lapse rate of 6.5 degrees Celsius per kilometer. Okay, there you go. Well, yeah, but it's still... Oh, no, that's not the distance. It's per kilometer. Okay, so there's a correction. It's not 6.5 kilometers, it's 6.5 degrees per kilometer. But still, that's pretty high above your head. So that it's still saying that within this area, there's no change in the lapse rate. This lapse rate is responsible for the behavior of refraction and air mass in those few degrees above the astronomical horizon, right? Do you guys know what the astronomical horizon is? It's not very... accurate, I don't think, in the way that I've looked at it. Even with Andrew Thomas Young's description of the astronomical horizon. Why aren't you switching over to that? Not sure why it went backwards. Astronomical refraction. Okay, astronomical refraction is the angular displacement of astronomical objects from their true geometric position. Okay, so when you're looking at the stars, that's not where the star really is, it's being refracted. The problem is, how do you know where it originally was? That's where it is right now. That's another thing aside. So astronomical refraction is astronomical, Now we're getting into the terrestrial. At some point out there in the distance where you get closer to the surface of the Earth and things get wonkier, that's where the astronomical stops and the terrestrial starts. The problem is that thing changes all the time. It breathes, it gets closer to you, it gets farther away, it gets bigger, it gets smaller, but it's always that same ether band through which you were looking. It's still that same duct of air. That's Wegener's term for it, was just duct. But my argument is that as you look out into the horizon, if there is confusion at the horizon and you get above it where you're going to start to see blue sky or whatever, that line, in my opinion, is where farther land is behind that you can't see. It's just like any other atmospheric condition that creates looming, stooping, sinking, mirage, whatever. That astronomical horizon is actually a nod in the direction of, yeah, the Earth just keeps going and going and going. That's why you call it a horizon, because that thing that's dividing that is made by the air. So what's behind it? More land, because that's the way the Earth looks to us. The floor rises up to meet our ceiling, and that happens at the focal point, which is typically somewhere in the center of your vision. And so so visibility near the horizon. This variability near the horizon is surprising on the average, is very surprising to the average astronomer, who has been educated to believe, indoctrinated, right? Educated to believe that refraction can be calculated accurately from the local atmospheric temperature. Wait, what a minute? What? You're telling me that refraction cannot be calculated accurately from the local atmospheric temperature and pressure? There you go. I'm going to read that again. I was trying to think. Okay. The variability near the horizon, the changing variables near the horizon. Thank you for that, Sea Lightning. Appreciate you hanging out here, man. If you guys have any questions or whatever, or if you want to include some thoughts here, but I'm just looking at atmospheric refraction with regards to how we see the horizon. The variability near the horizon is very surprising to the average astronomer who has been educated to believe that refraction can be. This whole statement is a negation against his indoctrination. The average astronomer, what does that even mean? Does he have to have a master's? Can he be a scientist like I am, just sitting here, reading about stuff and then going out and looking at stuff and then coming back and saying, what I'm reading isn't matching what I'm seeing, or at least my interpretation isn't matching this, and why is that? Once again, to the average astronomer who has been educated to believe that refraction can be calculated accurately, that the implication is it can't be. All right. We are going to discuss and see here that there is a statement against using standard atmospheric refraction. Apparently, without consulting anyone interested in atmospheric refraction or extinction, a handful of experts agreed amongst themselves to adopt a particular temperature profile. This is my argument against their whole supposition that the Earth is curved. So apparently, without any physical measurement of Earth curvature, everyone responsible for our scientific education decided or agreed amongst themselves to just simply assume the Earth is curved as an explanation for what's happening out there. When you peel back the onion of the narrative that we've been given, it's all based on these observations that I see and you see, and then you just had more people behind you saying the earth is curved. That's it. That's it. Why are we not, in terms of given our education, with all of these opposing forces in the world, all of these polar opposites of men and women, children and adults, parents and grandparents, or whatever, like all of these relationships that we have, we're given both sides to a certain extent, right? But when we're talking about the science that we're being presented with in school, there's no opportunity for us to be told, this is an idea about how to do this, about how we see what we see on the horizon, and this is an idea. Which do you think is like it? But again, you then become just a peer review. It doesn't matter what I think. It matters how the observation that we're seeing is best understood and interpreted. And for the sake of argument, it could go to either side. Yeah, I mean, I've heard that too, but Sea Lightning, if you don't know the channel Sky Free, I'm trying to think if I did this. I might have made a response video to it, but they do a lot of great hands-on, small-scale tests. And I've heard that too, but I've been out on the field so often that it's not always consistent. So there's not consistency in that statement. Regardless of whether or not that's accurate, the ability to see as far as we can see and no farther is always due to the condition of the medium, whatever that means. If there's uniformity between the temperature of the air and the temperature of the water, or whatever. The thing that I'm trying to remember about what I saw with Sky Free was they showed a very close relationship between the air and the water, but there was a mirage. And then they showed where the opposite was, the temperature profile was the opposite, and you could see farther, is what I'm saying. They have it on their channel where they have that documented, and I'm just going to take it for granted that their measurements were accurate. But when they measured uniformity in the air and the water, there was a mirage there still. So apparently, without consulting anyone, a handful of experts agreed amongst themselves to create a temperature profile beginning at 15 degrees Celsius at sea level and decreasing linearly by 6.5 degrees for every kilometer. Decreasing linearly, vertically, but it doesn't decrease for a kilometer. So that means everything in the corridor that I'm looking at, because I'm not taller than a kilometer, they just flatten it and call it one thing. But why wasn't it a mirage? Why did you choose sinking? Right? Because sinking is the default environment. Wait, hold on. Going to this way? Nope. Man, oh man, how did this get screwed up? Main mirage page. I want to get to the glossary. Glossary. There we go. Looming. Okay. When we start to read this introduction, this is the explanation for what typically you should see because of the standard, right? This standard is Andrew Thomas Young is describing, here's the target right here. Here is where your eyesight hits the target, which is right here. just this much of the target. So where is the rest of this target? My science is it's all right here at the horizon, but we can't see it due to the conditions of the medium through which we are looking, which includes the foreground, boop, and then the background, because this is not to scale. This target is never going to be to scale. So the entire, because well, it's like, this is what the question is. The question, when I have had these examples in my documentation on file, and that is my captures of targets visually, right? So think about this. If you look up any of these astronomical texts of the past, all they have is text where they have to tell you what they're seeing. That's, for me, a bit too abstract. When they say that this is what I saw, I'm like, I don't know what the hell that looks like. Like what? Like there's no pictures. They couldn't take a picture. So my research is more pictorial. It's more visual, where I can then give you a picture of what I'm seeing and explain why I think I'm seeing it. Whereas opposed to the text of the past, the prose that they were using wasn't as clear or specific. Anyway, my point is that I have had people, when I've explained this to certain people that are on the opposing side, their question is something like, how can there be two effects of the atmosphere that you're looking through? And the answer to that is, depends on where the horizon is. Now, I've never said this before, but I'm saying it right now, so this is documentation of this idea. It's not in writing, it's audible, it's being recorded. The floor of your visual space and the ceiling of your visual space meet in the distance, and that division, that dividing line, is called the horizon. So that's what we're talking about, because I don't see things in the sky like I see them at the horizon. I don't see things on the ground like I see them at the horizon. When I look straight down to the ground right here, I can see worms and birds and bugs and dirt and cars. But when I get out there, shit happens. But I'm not out there, so I don't know what's going on out there unless I have another me out there. So if you have sinking, right, just follow me with this, and I'll just do it right here with Andrew Thomas Young's example here, okay? This target is not at the horizon. This target's not at the horizon. The horizon is 3 miles away from the target. So there's distance between this line and the target. Normally, we don't know what that is because we don't have this simulation just making shit up and saying, oh, I'm just going to put the horizon just right about here, right? How did he determine, because for this standard atmosphere, this point, right, this is your line of sight. This is your line of sight. This is your line of sight, and it touches the surface of the earth, which is the horizon, which explains why you can't see anything beyond it. Why don't you see more water? Why don't you see more water? Why don't you see the base of this target? Because it's behind the curve. No, it's not. This is the limitation of the visible water created by refraction, by looming, this is my science, by raising up the floor to this position. And at this position, 3 miles away, the conditions change, which is why you see this target presented this way. However, if I were to, I guess I could do this with the images I have of the Chesapeake Bay barge, because I have the Chesapeake Bay barge in a mirage where you cannot see the body of the hull of the barge. You cannot see it. You can't. And then within that same channel that the barge is going through, in different conditions, you can see the entire barge. Right? So the idea should be that in this instance, like, this is what this looks like in sinking.
where, yes, I agree with this. This happens. I've seen it happen. I've seen targets cut off by the horizon. I've got photographs of it. Absolutely. But if you had a target that didn't move and these conditions were different, you would see the horizon beyond the target and the target in a completely different orientation because it's distorted because you're looking through 6 miles of atmosphere. But we should be able to see the difference between looming isn't just bringing up a little bit of it. It's not just bringing up a little bit. It brings up the entire thing. What's going on? Flat, is that air or ire? Flat ire. Flat tire? Flat tire. If I'm right. All right, let's get back to this. All right, here we go. Here it is. Ready? With the advance of aeronautics and the science of artillery, engineers and specialists in these fields have come to require a specific knowledge for the varying states of the atmosphere from the ground to very great elevations. This has led to the introduction of a conventional, it's just convenient to talk this way, term known commonly as the standard atmosphere, which pretends to specify the normal or average condition. As is well known, the standard atmosphere is never found. Let me just highlight that real quick. As is well known, the standard atmosphere that all of y'all globe flake scientists out there, don't be a globe flake scientist, okay? Just don't. Standard atmosphere, standard atmosphere, standard atmosphere. As is well known, the standard atmosphere is never found. That is, at no time or place do standard or average conditions at all altitudes simultaneously occur. All right. So this paper was just for the citation of this. Okay, so all right. So what am I going to do right now? What am I going to do? Am I going to putz around and try to create why? Like, why am I doing this? We got to get somebody out here to get somebody out there to see this kind of information because, look, I just don't get it. I do not understand why this information has not impressed someone who has the ability to at least get the ball rolling with research, you know. I find it interesting and strange and disconcerting that the PhD Rod Nave, with whom I had fantastic conversations, when I asked him, is there anything you can do to help me with this? He was completely silent, dead silent. He would not promote this research, even though you can go watch all 3 of those interviews where he just inundates me with just profusions of accolades of appreciation for my research, and yet he will not push it to be considered. Hey man, it's like a screenplay, right? Just read this kid's screenplay, right? He asked me to write an article to explain my scientific interpretation, and yet there's no how did he not pass this on to someone who could look at it and go, yeah, this is like groundbreaking. Why is it groundbreaking? Because I and the other researchers like Skyfree and Wide Awake and others, we're not saying what the science is saying. That should be like a front page ticker tape across the bottom of your news channel information. This just in. New science challenges the claim that the Earth is a globe. Like, that would be fucking monumental, bro. And then the argument is, well, the reason why it's not out there, travel, is because it's a lot of bunk. Like, all your science is bunk. That's why no one's picking it up. And your evidence for that is just your own ad hoc creation in your mind as to why, you know, your hand wave dismissal is the reason why everybody else is just hand wave dismissing it. I don't know, man. Okay. So the other day, the other day would be yesterday. Maybe I'll just walk through this with you, because this was why I was frustrated with Andrew Thomas Young and his response in his email is, you're taking my attempts to explain this stuff way too serious. He's like, I don't know what the fuck I'm talking about. Basically, you're taking my attempts to explain what I think is happening way too seriously. I'm sorry, this is science. That statement is just mind-boggling to me. Right? This is the Muppet Vision view. The ability to see yourself from the side, right? This is a side-on view of what this model is trying to indicate. All of this, you see all of these lines? Do you see this line? Do you see this line? When can you not see that line anymore really as its own line? Like, I lost it right about there. Like, this is what we're talking about that's happening out here. This... Okay, so then this conical point is your eyesight. That's your eye line coming right out here. And 0 is your horizon, right? Or not your horizon, basically, but because sometimes the horizon can be below. I get it, okay? You're looking straight ahead, okay? You're looking straight ahead, all right? 0 is basically that horizontal plane that's above the Earth. So that's fair enough, right? Okay? Like, if I wish I could just, like, be... and just have this program show up so I can jump on it. I can't do that. Like, man, maybe I need to get AutoCAD or something like that and work on this. Maybe I need to do that. But my point is to show you that maybe I'll just do it. Maybe I'll just do it. I'm gonna do it. I'm gonna like do something. I don't know what I'm gonna do, but I'm gonna do it. Let's get over here. Let us start a new document. And I'm gonna drop the chat off my visibility radar. So then I need to change this to landscape. Page orientation. Landscape. You know, like, I wonder if there's somebody out there screaming at me like, dude, there's a better program out there, man. Have you ever heard of XYZ? Nope. Oh my goodness. I need a benefactor. Alright, so get these templates. I don't know why those are in the way. Okay. Now, let me get my handy dandy PNG. Alright. Give me a second. If you're hanging out, can you guys hear the music? I hope you can hear the music. This is the sultry sounds of Alex Michael, better known as Conspiracy Music Guru. This is his instrumental albums, True Solfeggio Volumes 1 and 2. Alright, let's go to the PNGs. All right, let's get our viewer. See, I can't just slide this guy around. See that? All right, so let me flip him. You know what? I'm not going to do this here. I'm going to do this in Paint. Do I have Paint open? I mean, paint.net. In the meantime... See, dysfunctional navigator, that's not true, right? He might think of it that way, but in reality, everything in his experience has made him the person that he is, which hopefully is the best expression of who he is for himself. Like, is he happy with himself? So, I mean, the whole thing about wasted time in the past, I just don't believe in it. I understand the sentiment, though, and it's pretty funny. I've met Danny, and I'm not gonna say anything disparaging, but you know, it's you can tell a lot about a person. All right. Thanks for being here, Dysfunctional Navigator. Please forgive my lack of attentiveness to the chat if you're interested in anything that I'm saying. Okay, this is the... Oops. I did want that. What am I looking for? Guys, what am I looking for? Paint.net. Oh, that's what I do. Open this in Paint.net. Okay. Nope. That's not what I want to do. I want to do this. And then I want to do this. Okay. See, this is what I'm talking about, right? Like, this is scaling. You know what I mean? Like, is this, he's a hobbit right now. This guy's a hobbit. So you have to scale everything back, which means it's a sliding scale, right? Like, this is what the air does to targets in the distance. It smashes them to hell. And then, like, if I had the ability to create a, let's see what I could do, right? I'm talking out loud for someone who has an interest in doing this. Like, here's the target. Ooh. All right. Let me do one thing at a time. Hopefully I can get my concentration back. Maybe I will do this real quick. Create a program to invert the image when the scale reaches a programmed coordinate, okay? Create a program to invert the image when the scale reaches a programmed coordinate. That's just a note for myself. Note to self. All right, so what we have here is a man, an observer. This is not going to be to scale. All right, he's on the surface of the earth, and his line of sight is never, ever, ever, unless he looks down. If he is looking straight ahead, his line of sight, which isn't real, it doesn't exist. There's nothing out here that is like a line coming from his face, right? This is all conventional. It's convenient to talk this way. This is the plane of existence that he's standing on. It's good old terra firma. But up here, he's looking straight ahead, and it's just open space. But his orientation is parallel to the ground. And no matter how far away this gets, right? If I do this again, can I do that? No. See, I wish it would just come in as a smaller file, but I have to keep doing this, right? So if I now scale it down even more, right? So this is the same man. Lines, lines, everywhere there's lines. Right? So now we are now looking farther and farther and farther, and he's still looking out here at this target. His eyes are never, right? The line of sight is always above the ground. Right? But the way that we see the world is like this. I'm going to try to make another little guy right here, just like the same one right here. Whatever. Okay, so here's now this. Now this is the way perspective works, okay? This is the physical reality of this side view. All we see out in the distance right now, right? This is the horizon for us. There's just a man standing there. So above the ground, we don't see anything but just the sky, right? We don't, okay? And this is the way he's looking. He's looking out this direction. And the ground is below him, okay? So now this guy here has his line of sight, okay? This is his line of sight up here. Okay? And I'm going to put a target here. Okay? I'm going to create a target. And it's going to be this, let's see. See, the problem with this is that it's hard. I guess that's it right there. Yeah, I'm going to have to get creative if I'm going to try to do this. All right, talking to myself. Oh, here we go. Derp-a-derp. All right. Okay. So I'm going to put this object out here. This object. This boat, right, is out here. Okay? So this boat is out here in the distance. And this is where the man sees the boat. Let's just try to be a little bit realistic. You know, it's hard to be specific here, but the side-on view of reality is this. This is a side-on representation of the first-person perspective. This man, when he's looking out, sees the ground do something in his field of view. And what he sees the ground doing is this. It is ramping up. From his nose to the target, it's being loomed up. Okay? Our experience in this environment through our optical corridor is looking through quadrillion, billion, gazillion, like innumerable droplets of water, spheres of refractive media. If you've never thought about that, just look up what makes up the atmosphere. Moisture, humidity. Even if the humidity is 0, there's water in the air that you're looking through. Otherwise, this world couldn't exist. That's the way this world is constructed. And the way this world is constructed is when you look out through water, it brings things together at a focal point. It focuses. You have all of these lenses interacting with each other, focusing, right? Like when you look out at a target and you're looking at something in front of you, it's clear. But you take it for granted that everything else around you is clear. And when you look over there, it's farther away. It's an adjustment right there. It's like this zoom, and zoom, and zoom, and zoom. It just depends on where your line of sight is. Right? So the appearance of our environment is as if the floor is ramping up. But if you were to just have someone exist and never think about this and then bring this up to them, they would have been like, I'd never thought about that. I just looked out ahead of me and everything was just straight ahead. You know what I mean? Like you have to be specifically, I think, thinking about this investigation, you know, which I think anybody would really, don't you think? Because it's the same thing with railroad tracks. It's the same thing with crepuscular rays. It's the same thing with watching something go away from you into the distance, and it gets smaller and smaller and smaller and smaller. Why does that happen? Because you're looking through lenses which distort and repackage and represent the target through that distance of lensing. It's like a magnifying glass. And that's what the air does all the time. It's just that when it's a stable view, you've got a pretty good stable environment, which happens in the air and on the floor. But when you get to this is now the other place. This isn't where I wanted to go. Give me a second. Nope. Poop on a stick. I have no idea why I ever created that curse, but I did. Poop on a stick. Where does it show just the mirage stuff with the focal point? I guess I could just show you right here, right? All of these points that are coming into your view this is what it looks like out on the horizon. All of this smudging here is all of the information out there in the distance fitting into that narrow band of space. You think you can see? Right? You mean the impenetrable atmosphere. I want to find that other... No, that's it right there. I don't know why I'm wasting my time doing this. I guess maybe I'm just trying to spawn some ideas. Right? That's what this all is just spawning ideas. I don't even know. It's crazy. Standard atmosphere. Does he have that? Yeah. Temperature profile, terrestrial refraction simulations. There we go. Okay. Again, it's just the information that you're looking at out here. That's what this looks like. So we should draw a person here. This is a person looking out here at the horizon. This is what the horizon looks like. This is his ceiling. This is his floor. Boom. Look at that. See what's going on? You see what's happening right now? This is pretty cool. This organic research. I like it. If you think what's being discussed here is interesting, I would appreciate it if you would share this content. And I will
bring up. All right, look. When the dew drops overnight, making grass wet, that is when the stars are crystal clear. Every time Mikey Smith horizontally opposed, I don't know what that, is that what you meant to say? I don't know what that means. Horizontally opposed, I don't know what that means. Opposed? I don't know what that means. Has recorded his best stars. Okay. All right, you saw the 7 stars that make out. I mean, I can see the Little Dipper here, but I'm in Colorado. It's much less humid here. When frost falls, it is called hoarfrost. That could be a time to see far distances, maybe a time to record the stars. Okay. That's interesting meteorological data. Thanks for that, Sea Lighting. I appreciate it. So if you're still here, I am imploring you to share this content and just bring other people here. And like, you know, they might not be paying attention, but they will chat with you in the chat. Have you shared the show? All right, let's get some more people here in the chat for you guys to hang out with. But I'm going to work on this process right now of depicting what it looks like. Right? This is the field. This is our field of vision. Okay. This is our field of vision. This is the horizon. Class. All right. All right. This is the sky or the ceiling of our visual corridor. Okay. This is the earth, ocean, or the floor of our visual. Okay. Thanks for still being here. Have you shared the show? Let's get other people being here too, if you wouldn't mind. Okay, so now this is where the horizon happens. And this black line here represents the amount of information in that small band of division that you see, right? So, all right, let me think about how to do this, man. This is going to be really interesting. Okay. Oh, that's a good way to do it. Oh, there it is. Oh, there we go. Okay, so now this is going to represent perspective. I don't know what you mean. Were you affiliated with what, Adam? I don't know what that means. Okay. Like, what do you say about this, right? What do you say about this where... Let's see. Maybe I should... I guess that's probably what I should do, right? All right. I am going to look for a photograph of... Maybe it's this. I'd have to change some things, but this is basically the idea. I'm gonna see where I've got those templates, because I don't see them here. Okay,
Were you affiliated with that website taken down? Just wondering, no biggie. Adam? Adam, what are you talking about? Okay. Here's something. What website? What is it, Adam? I'm soon just like not going to be paying attention to you, bro. What website? Were you affiliated with that website? A Plain Truth. I'm not a Plain Truth, bro. I'm the Plain Truth. A Plain Truth is a completely different person. Ugh. Fucking A, man. You just come out. Were you affiliated with that? And then there was nothing. Website taken down. Bro. Alright. I need to get... Let's see. If I go to... my trips... 23... Chicago. Do I have any photographs of... Alright, this is Chicago. Let me go to trips. Milwaukee. But at the same time, I'm trying to think if I have anything visually out. You know what? Sheesh. It's just unending. Okay, you're trying to share a link. Is that what I hear you doing? Yeah, I'm not going to try to figure out how to allow you to share links, but whatever. Okay. I'm looking for good examples of perspective. Ooh. That would be good. Because I was taking those pictures. Alright, I'm going to put this in my other folder. You know what I mean? You know what I mean? Alright, let me think through what I'm thinking through right now. Oh, here we go. So, like, this is perspective. You know what I mean? And this is zoomed in. Do I have it zoomed out? Like, that's zoomed out. Right? Okay, so that's zoomed out. This is what I'm talking about in terms of how you see. This is a still frame of the frame rate of your eyeball. Okay? When you have something in focus like this tree, everything else beyond that you're not looking at looks like this, but you can't see it because you're not looking at it. But if you were to take your eyes off this tree, if you were to take your eyes off this tree and then focus on this woman, that's what she would look like. If you had the ability to focus your f-stop, right? The shutter, the opening of the shutter, right? The more light you let, like this is what we're doing here. Okay? But when we're looking out into the distance, things proximate to us that we're looking directly at is in focus. We take it for granted that everything else is in focus too, but I'm only looking directly here. I can see the camera, but it's not clear to me until I look at it. And now that I've looked at it, it's clear, and now this part's blurry. Right? Like, this is how we see through the medium through the medium of which we are looking through. And we see that the apparent rising of the sidewalk comes to our central frame. This woman is here ahead of us. Right here in the middle of our front. Like this is the far, like this would be where the horizon is. Okay? Alright, I gotta get back to thinking about what I was thinking about. Making images of horizons. So I want to find a better, clearer... The great thing about this is I was here for such a long time. I have gazillions of photos, but I have to find the right one with perspective, like this one. Okay. Right? This is the way we see. As you are looking over the ground, you're not looking at the ground the entire time and raising your eyes. You're just looking straight ahead of you. And as you look straight ahead of you, everything rises to this point of the horizon, and the angular size of everything corresponds to the distance of that object through the medium, right? So let's see if we go. I've got a red light here, tail 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 light here, but it's getting smaller and smaller and smaller. And see how small the tail light is right here? My question to you is if this car gets far enough away, do you think you will continue to see that even though it's directly in front of you? All right, so if I do this, no, I don't know if I. Just trying to think if I want something that's far away or close to. Like this is. Right, so here's my horizon. So maybe I should find an elevated picture. You're gonna get an eye for how I take photographs. Taking pictures with the sidewalk stamps. Oh, look at that reflection in the window. Did I ever pay attention to that? No. Ooh, that's a good one. Look at that. Look at all that, right? Like, why can't you see shit down there? Why can't you see anything down there? Can you see, like, you can, right? And then if you zoom in, did you know there were two people right there? Like, look at that. Right? Depending on the conditions. All right, so this is a pretty decent example because then I can zoom in on something that's there, right? All right. Which one was it? This one? All right. Now, if I'm going to... Is this what I want to do? What do I want to do? Let's see if I can... Why is that not changing in its opacity? What the crack, man? Oh. That's not what I wanted. Okay, I see what happened. Undo. Undo. I have to be here. Add as a layer. before. What the heck? Okay, stop. I wanted to keep the parameter. I wanted to like have edges to explain things in. What is right here? Like, oh, there you go. Why is that happening? How do I have that not happen? All right. So, a needle pulling thread. Alright, if I'm going to use this as a teaching tool, right, I'm going to have it start here. Right. Let's see what I meant to do. This is what I meant to do. So then what I want to do here is diagram the compression of your eyesight in this space right here. Right? Okay. So then I need to bring in my handy dandy PNGs. Okay, so bring my guy in. Alright, so here's my guy. Alright, so he's standing right here, and this is where he's looking. Okay? Alright. So now comes the tedious part of... I guess I can just copy and paste, but it's got to be a... So his line of sight is coming out to here. And the floor that he's looking at is rising up. Right? Let's see. Let's call that 4 blocks, 4 city blocks. Alright, I think I'm going to do this over again. Oh, there, I could have done that. Alright. No, that's not what I wanted. Why is that not just... Okay, get out of here. Okay, so here's the reality that his street is going out directly in front of him. Okay? This is the way it looks in reality. You wouldn't see this white line. You would just see him looking out, you know, directly ahead. Okay? So then add a layer. Should maybe make them small enough and then just copy it. Just keep just pasting it, right? All right. The thing that stays the same is his line of sight. His line of sight is directly in front of him. But the way the floor and the ceiling work in his visual space is compression and looming. Compression from the top and then looming from the bottom. The floor is being loomed up. This is being loomed up. How? Through the medium that you're looking through. Through which? The witch threw. What did the witch throw? Okay. Again, I'm just walking myself through this as well to think about how to communicate the idea of what happens here at the focal point, or the vanishing point of your visual space. The limitation of your visual space, if there is nothing between you and the horizon, the limitation of that visual space is the limitation of your visibility because of the condition of the medium through which you're looking. Otherwise, sometimes you don't see very far because of the conditions of the day. Maybe there's whatever. Okay. Still trying to think through what I'm doing here. Oh, then I need to do the ray tracing thing so that it shows all of the compression from the floor to the ceiling. Okay. That's not what I want to do. Oh, yeah, I can do it. So I need another one of him. And I didn't do it this time, did I? I should just copy and paste it. Okay, copy and paste it after we made this small. That's what she said. Copy. All right, now. Let's say this stretch of sidewalk in front of our viewer is, let's see, what do you think? A half a mile. I don't know, right? Half a mile. Let's say this stretch of sidewalk in front of our viewer is a half a mile, represented by the two lines, one from his eye and the other the ground, right? Let's say this stretch of sidewalk in front of our viewers, this one right here, boom, let's say that stretch of sidewalk is a half mile, represented by the two lines, one from his eye, you can see that, and the other from the ground, we can see that. Okay, so he's looking, this is him looking 5 miles straight ahead. All right. Let's go right here and say the way the world presents itself to the viewer can be seen in the photo. Do you see the sidewalk getting more and more narrow, right? This is like railroad tracks going into the distance. The way the world presents itself to the viewer I did it wrong. Can be seen in the photo. Do you see the sidewalk getting more and more narrow? Is that actually happening? Do you think you live in a wonderland where perspective is how the physical world actually is? I don't know if this is relevant at all, but right? So if you were to like, here's the argumentation. You ready for this? This is the argumentation of Alice in Wonderland, Lewis Carroll's abstract, mind-numbingly bending, just Alice is looking down the corridor, and the corridor gets smaller and smaller and smaller, and Alice thinks to herself, I'm not going down there. I don't want to shrink. I don't want to get smaller. I don't want to disappear into nothing, right? Because I can't see the end of that hall. Like, that's the idea here. I'm never going to go anywhere because things get smaller when they go away. And then they disappear. Like, that's the absurdity of thinking this way, right? You know that your feet are always below your eye line, and you are walking straight and you're looking straight. Those two lines are never going to meet, but they do in perspective. So the whole philosophical absurdity of what's the sound of one hand clapping, or if a tree falls in the forest and there's no one there to hear it, does it make a sound? Those are absurd, inane philosophical musings that can't happen because they don't exist. Show me something and ask me a question about that. But ask me to imagine something that doesn't ever happen. People don't ever shrink, so that's not something to think about. All right. Totally don't even know if I finished my train of thought there. The way the world is and the way the world is interpreted are completely two different things. You have to look at something orthographically. That's what it looks like orthographically. Right? But within that orthography, within that space that you're looking at this way, someone else is on the other axis looking across your vision, right? So he's looking this way and I'm looking this way. And that point, somewhere where that meets, is not going to look the same to both people. But the thing that's going to be the same and true for them is the floor and the ceiling are going to appear to come together in the distance. Even though they can't physically. It's impossible. Although the sky is always touching the earth because we live in that same environment. It's just at a different grade. Right? You get what I'm saying? Is anything going on out there? Mobius Maximus. What's going on, man? What's weird to see is the same level line running straight through from a side view. I think I know what you mean. I think I know what you mean. All right, so what I'm going to do right now is now try to bring in lines from the ceiling to the floor. All right, so this is now going to be the end of this. That's what I should have done. Right? I've never seen a long bridge from the side where the distance between the water and the bridge gets smaller. Well, I mean, if you think about it, I could probably go to my files on my Pontchartrain visitations, right? I understand what you're saying, but I disagree with you because, I mean, you'd have to be, I guess, no. If the bridge is far enough, if the bridge, like the Pontchartrain causeway would be one. If you went into the middle, and then you looked straight ahead of you, and then you just went and looked this way, the distance would be far enough away that that would happen, right? That would happen. Unless I'm misunderstanding what you're saying. Okay, so now, let me explain this real quick so that I can get that out of the way. These conceptual, right? So that would have been the thing for Andrew Thomas Young. To be honest, Andrew Thomas Young, for you to be honest, you need to go back and introduce all of your information as conceptual, hypothetical scenarios that you think are accurate. We don't see lines of perspective unless they're man-made like this one right here, right? But if we were standing out in the middle of nowhere, the Earth would still look this way. But we don't see lines of perspective. We don't see crepuscular rays of our vision, right? We don't see rays of light. Rays of light are not anything but conceptual. These conceptual lines represent the way the ceiling and the floor appear to converge these conceptual lines represent the way. So like what I'm doing right now as I think about this, because I want to make I want to do a presentation here at our local library. They have Thursdays where they let people have the floor. So I need to do this. So basically the idea would be just to explain without referencing the globe. Without referencing the globe whatsoever, because there's no need to, right? Just explain, and there might be art teachers there and whatever, they know. But then when you talk about then what happens on the horizon, you just let it linger there, that's the vanishing point of the rest of your extended vision. Otherwise, it would just keep going and going and going, just like it looks like as you stand in the area that you're looking in, and you look up and you look up and you look up. The Earth just keeps going and going and going and going. It's just that you can see it. Right? So then if you think about this, I think I have it up here, right? This guy right here, right? If you kept zooming this out and zooming this out, right? Like if you, let me do that. Can I do it in a smaller? Let's, I think I did that. Okay, now what I'm going to do is create an impossibility. Like this is how small, like this guy is so infinitesimally small, right? It's like Ant-Man, all right? So there he is. And now, right, the way the world is, again, the ground, we're not talking about elevation, this is the ocean, right? This is the ocean. And this is what it is. The surface is always parallel to his vision. All right, so not using the earth because the earth is going to have valleys and whatnot, okay? But you're looking over the ocean. That's never going to change. This is never going to change until you hit the edge, which would be land. Right? But if you can't ever see land, that doesn't mean that the land's not out there. Because guess what? If you just get in a boat... If you just get in a boat and sail away from this guy, right? And then you get to this point, right? And then you become the new, well, let's make it real because, right? Because this boat's not going to be the same size it was that it left harbor. Right? Let's copy that. Let's post that. Let's paste that. Let's get this, right? Because the boat looked like this when it was in front of you. Why is that blurry? Oh, because that's how blurry the ship is. That's wild. And kind of true to life. Okay? So now the boat is here. And then you copy and you leave it. And then you paste it. And you bring it out here. And it's smaller. Okay? Then you copy, and then you leave it, and you paste it, and you bring it out here. And it's smaller. Yeah, see? And then, if you were to, go to the perspective aspect, it's going to get smaller and smaller and smaller until it gets to the point of infinity. Okay? So there's the guy looking at the boat, and the boat's closest to him, and then it gets farther and farther and farther away, but he's still looking over. This boat is never going anywhere but farther away. There's never any... This is not the result of curvature. This is not the result of curvature. So the distance that he's looking at is just straight. Every time you move across the water, you're moving parallel from where you were before. You're not any higher. You're not in a river. When you're on a lake or you're on the ocean, you are always level, despite the crests, dead calm, level, whatever. Storm, tumultuous, you're going to try to find your equilibrium, but once it settles down, there you are, sea level. You keep sailing that way, the water's the same everywhere you go. It doesn't start to curve at one point. That's absurd. Who told you that? It's absurd what we've been told. Okay. I don't know what freaking time it is. Hardly even know what day it is, man. Okay. Think about things, create things. These are going to be templates. So I need to create a file to save these in. So I might as well do that. I'm going to say save all. All right. Mirage paper. I'll do a new folder of templates. And diagrams. Okay. Oh. All right. And so this is just 1.1. And this is going to be 1.2. 1.2. Oh, in here. Why did that show up there? You would necessarily have to claim the ground rises, not optically. You cannot demonstrate a head-on view perpendicularly. You cannot demonstrate. Yeah, I mean, I know it. It's kind of weird, right? You cannot demonstrate a head-on view. Well, I mean, you can, yeah, you can. You can diagram because you can make the ground do what it doesn't really do. So you can. It's the magic of Hollywood. All right. I just want to find out why it got Mirage Paper, templates and diagrams. See the 1.1. Why is that? Where did my 1.1 disappear to? Save as. Templates and diagrams. Open. Oh, I don't want it to be as a. I want it to be as a P or a JPEG. Okay, and then this one I need to save as a JPEG. Okay. Save. But I want to also reduce this field. How do I reduce this field? I think I have to, all right. Yeah, but for some reason this is just stimulating my existence right now, so I'm all about this. So let me. Oh, you know what? I left this by itself, and I didn't complete the sentence. These conceptual lines represent the way the ceiling and the floor appear to converge. All of the physical information in that distance, all of the physical information in that distance is getting visually compressed into a more and more constricted visual corridor. Okay? Imagine trying to convince people the ground slopes up in every direction while simultaneously trying to convince them it also slopes down. Oh, man. Yeah. That was good. That was good, man. I've been thinking about that. I read that recently, but it was not said that way, and you said it much better than the way it was. The way the article that I was reading was talking about that. Oh, it was a quote. It was a quote about, and I have it in the yesterday's live stream. That the quote comes from the Observer, and he says, "We saw the concavity of the Earth, right? Because everything was rising up, and because they had such a vast, they were in the middle of nowhere. So like they could do a complete 360 and see everything, and it all looked like doesn't it look like it's ramping up? So we must be in a contact lens existence." But you said it a whole lot better, because yeah, it's sloping up this way, but the Earth's curved, so it's going down. What? Yeah, that was good. Okay. All of the physical information in that distance is getting visually compressed into a more and more constricted visual corridor. In other words, what you are trying to do is see objects and targets in the distance trying to, how am I going to say this? In other words, what you are trying to do is see objects and targets in the distance competing. No. What you are trying to do is see objects and targets in the distance take up the same visual space, which depends upon the angular size of those targets, right? Because you have different shaped things in the distance that occupy that space. You can't see anything if that space is occupied. And then you have other objects in the distance that have larger angular sizes, so they take up more visual space, but then everything in the distance is just coming together. It is just, it's again, we live in a simulation that is created by the environment in which we exist. The air, the water in which we live. We are aqua men and women, okay? You are breathing water right now. I don't know if you understand that, but if the atmosphere, if you type in atmosphere, what creates the atmosphere? Atmosphere. What creates the atmosphere? Let's see what we can come across with just a few references. Aight. Let me be right back. I'm going to refresh my coffee. Oh, look at the poor flat earther. He's learning science. Look at this guy. All right. What is Earth's atmosphere? Atmosphere of the Earth is composed of a layer of gas that surrounds the Earth. It is known collectively as air. It's funny. Where did I look this up before? Because one of the first things it said was that it was constituted of water particulates, right? Okay, let's do this real quick because I don't want to keep adding tabs. That's one of the things that I am horrible at, is I add tabs like crazy. Okay, let's add a tab here. Let's add a tab here. And let's add a tab here. Yeah. It is classified as a fluid. Yes, correct. We are aquamen and women. The atmosphere is a mixture of gas. That's why, okay, listen. That's why when you look out in the distance and it's waving and crazy like that, it's because that's what it looks like when you're looking through water at the pebbles, right? In a stream. You know, there's convection out there that conducts the energy, which is all of the atomic molecular gases that you say make up, right? The atmosphere is a mixture of gas that surrounds the Earth. It makes life possible by providing us with air to breathe, water to breathe. They meant to say water to breathe. Some of the Earth's gases. Alright, that wasn't very helpful because it didn't say what I wanted it to say. The atmosphere of the Earth is a layer of gases commonly called air that surround the Earth and creates and causing water temperatures. No. So, but both of those things were mentioning solar radiation. The atmosphere is composed of nitrogen and galaxy particles or aerosols from a variety of sources. Like what? Reactive trace gases. Many trace gases are removed by the atmosphere. Chlorofluorocarbons. What? That is so weird that I am not getting a result that said that, like, the most simple thing was that it's made up of not only the gases that they were mentioning, but also just water particulates. So that are so fine. Right? So let's see if we can find something. See what NASA is going to say. And then we'll go to Noah, I suppose. How did Earth's atmosphere form? No, that's not what I want to know. Right? You know, if you just think about evaporation, right? It's just water becoming smaller water. That's all. It's not dividing into hydrogen and oxygen and nitrogen and blah, 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 whatever. It's becoming smaller water. When we talk about the Earth's atmosphere, imagine a layer cake. Essentially, the Earth's atmosphere is like layers upon layers of gas, right? Which is water, layers and layers of gas just compressed, right? So then when you look out in the air and it's compressing, it's watering. It's becoming watery, you know, visually. Man, oh man. This is so crazy that the interplanetary space. Okay, let me just do this. Is the atmosphere made up of water particulates? So just real quick here. Earth's atmosphere is composed of blah, blah, blah. Trace amounts of water vapor. Right? Water vapor. Okay? Water in the atmosphere. Phases of water. Water is an unusual substance. Whatever. 3 phases of water. Blah, 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 blah. Vapor, liquid, solid. Okay. Dynamic mixture, 2 gases, blah, 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 blah. They are indeed important for maintaining life. No. Water vapor has been removed from what? Doesn't say anything. Some of what is in the atmosphere is not gas. Particulates of dust, soil, fecal matter. Oh my gosh, whatever. Okay, I'm off on a dumb tangent. Close this down and get back to this. Okay. All of the physical information in that distance is getting visually compressed into a more and more constricted. Like, I'm just describing what I see. I don't need a mathematical equation to explain this. Andrew Thomas Young. I can say what I see, and it's accurate. You know, like, why is this happening? Why do you think this is happening? Right here. Why do you think this is happening? What you are trying to do is see objects and targets in the distance take up the same visual space, which depends upon the angular size of those targets. Right? So that maybe I should just try to create this manufactured I'm just thinking in my head about shit. Okay, do I need to do anything here? I guess maybe if I just did another line of vision over and over and over again. Copy and paste. Nope, I don't want to do that. I wanted to bring it down. Nope. Okay, I'm gonna have to go all the way in. Right there, boink. 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 Alright? That seems pretty clear to me, guys. I mean, like, listen. Okay, and then here's his line of sight, right? Here's his 0. Alright? Boink. Alright, so again, so now at what point, right? So this man is looking this way. At what point does what's around him in his periphery, come into his vision? At what point do we start getting information? We start getting information here and here and here, and then it goes away and it goes away and it goes away, right? I don't want to walk down there. Those people are small, right? So here's now where I will say here. This, nope. It's not what I wanted. I'll say focus at the vanishing point. Can you see? Oh yeah, I'll just say, can you see anything in particular? Right? And then I'll just draw a line to indicate what I think is possible. Like right here, as he's looking through, right here, this is this line represents the beginning of the viewer's field of view, which this line represents the beginning of the viewer's field of view, which is what the photo presents, right? This line represents the beginning of the viewer's field of view, which is what the photo represents. Okay? Boom. He's looking through, let's say he's looking through the binoculars, and this is where the binoculars are, and that's as soon as he can look, this is exactly what's in his field of view. Right? Boom. Yeah. Except in reality, his field of view is much wider, right? It's not this little narrow snapshot. Whatever. All right, so now what I'm going to do in the next page is I got to turn the orientation again, right? Did I not do that before? Rotate. Okay. So now I'm going to bring in where was I before this? Oh, the PNGs are right here. Nope, this isn't where I was. I need to go back to you. Put this in. Okay, oh. Right, so if I... How can I... I wonder if I increase... Yeah, let's do that. Increase it by 300%. I don't think that did anything. Resize by percentage. Increase the size by 500%. Wonder if my CPU's getting overhauled right now. I can't play the music. Like this is all glitching out. This is not what I want. I think it is. See how long it's taking to render? My CPU's overloaded. Alright. This is not what I want, so I'm going to undo this. Okay, alright. I gotta wait for this circle of death. Wow. Derp, man. Alright, where am I here? Here, okay? Undo this. Undo this. Now, if I zoom in, right? So I'm zooming in. Is that where this is going to get saved? Alright, so... I think I could probably tell that there's two people there now. But I'll just bring it in one more because you can see there. So I'm just wondering, again, if this is going to get saved this way. Or how do I... Yeah, see what's happening? This is not enjoyable. Let's do this. And now can I crop the bottom? No, that's not what I want to do, I don't think. No, that's not what I'm trying to do. Alright. You see what I'm saying? Like, I'm going to zoom in here. Like, I want to make this bigger. Alright, let me see if I have to do it this way. Alright. So now, we'll just use that column, because then I think that this should be... Why is it doing that again? I just released that. Okay, how do I crop this? Crop to selection. Oh my gosh, I don't even know. Okay. The only way I know to do this is get out of this, open another program. And save that here. And I think this is probably like 1.3. Rio de Janeiro. De Janeiro. What does De Janeiro mean? I know what Rio means, but what does De Janeiro mean? Alright, so now that's saved. Now I need to go here. Excuse me. I am going to remove this. Bring it down here. Alright, and now I need to go to this. This, open this. Oh no, look there. It is correct. They're just showing the underneath. Nope. I don't know, man. Yeah, like there's something here, so I'm gonna get rid of that. Okay. Alright, so now this needs to be opened in paint.net. Okay. Alright, so now I have to think about how to utilize this space as much as I can. I think I'll just do this for right now. This photo is enhanced or zoomed in. Were you able to discern the two pedestrians? You know what's interesting to me right now is that I'm thinking about this is that that's so wild that you can actually make these out because like you can't get closer here though, right? That's the point of infinity there. That's the point of infinity there. That's the point of infinity there. Like if you zoomed in on that, it would just become anyway. So where did my text go? Man. Where did my text go? Whatever. Right? Were you able to see the two pedestrians? Like, what else? Is there anything else that needs to be said here outside of just repeating oneself? Or do I need to do a diagram again of the smashing of the information into a compressed cone of space. Maybe if I make this large enough. Just change to 60 maybe. I guess 55 is fine. We'll just leave it there at that. I don't know, maybe 54. Were you able to see the two pictures in the original focus? I would hate to have to make this over again because of the typo. Original. All right. 1.4. Let's go and check that. Okay, so we're looking at this. We're looking at this. So if I'm going to use this, I'm going to have to put tools in here, or text, I mean. Okay. The viewer's line of sight remains parallel to the surface, which in this example is water. The reason for this is the reason for this water is the best surface over which to make observations. The reason water is the best surface over which to make these observations. The reason water is the best in these observations is there are no substantial, consistent elevation changes.
the surface of water. The surface of undisturbed water is flat. At every distance. The viewer's line of sight remains parallel to the surface, which, in this example, is water. The reason water is the best surface over which to make these observations is there are no substantial consistent elevation changes. The surface of water, undisturbed, is flat at every distance. Okay? So now, this side view presents a greater distance over which the viewer is making his observation. What is it he is? I don't know if I can't, like, at what could he be looking? At what could he be looking? What's he looking at? At what could he be looking? At what could he be looking? What? You mean what's he looking at? Hey, you never end a sentence with a preposition, mate. All right. Turn off that noise nuisance. Okay. At what could he be looking? Lo and behold, he's looking at this sailboat. Okay. The diagram below, I'm gonna have the diagram, the A diagram, which is gonna be the first boat. The A diagram at a distance away over water. The B diagram represents the apparent looming up of the floor in that same distance. Okay. The A diagram, this is going to be A. And then see how it narrows? It narrows. So then the B is going to go here. And I'll put B down here because it's going to fit in a wider space. Alright, so B is there. Or maybe I'll put B right here. Alright, so B, and then you can see that the indication is it's sloping up. Okay?
this lower diagram. Like, I just was thinking, like, that would be hilarious, right? Alice in Wonderland, she's walking down the corridor. So in her perspective, she's getting smaller and smaller and smaller. She's like, she is experiencing her physical compression. And then you and I are watching her walk across the park, and she's just still staying the same. You get that? That's fucking hilarious. Like, that's so funny. Because it's true at the same time, right? In her mind, as she walks into the distance, she's getting smaller and smaller and smaller, because that's what's happening in the distance. Visually, everything's getting smaller and tinier. So why wouldn't it be that when I get to those places that I'm that small and tiny? And I just keep walking and walking and walking, and nothing ever changes. It's always the same thing. But it looks like I'm being compressed into this fine little point of non-existence. But as I continue to walk into the distance, existence continues into the distance. It's just that you can't see that distance continue at that point, because that amount of information is infinitesimally astronomical. I wish I could type that out. This lower diagram represents the point of view called perspective. I'm gonna have to make this smaller. Ah. Okay. This lower diagram represents the point of view called perspective. A sailboat in proximity takes up a certain amount of your visual space. Referred to as its angular size. Its angular size will change but not the physical. At the same time, that ship's staying the same size while shrinking. This lower diagram represents the point of view called perspective. A sailboat in proximity takes up a certain amount of your visual space, referred to as its angular size. Its angular size has... No, that's not true. It does have a relationship to the physical size, because the physical size determines the angular size at that distance under those conditions. Okay? Its angular size will change. During a live observation, its angular size will change, but not the physical. Within perspective, there is a subcategory known as foreshortening. Foreshortening. I'm gonna have to cut this part out. so I can write over it, but let me finish this. This term refers to the appearance of distant targets vying for the visual space. Right? Let me see if I can do this. This term refers to the appearance. This term refers to the appearance of distant targets vying for the visual space. This term, that's not it. This term, foreshortening, refers to how the floor presents the compression of information at every measurable. This is really elaborate, right? But this is what I'm doing right now. Okay, let's see what Google has. If Google can let me like, and that's I'm like, oh, that's a better way of saying it. But this is the way I'm saying it. This term refers to how the floor presents the compression of information at every measurable distance. So that targets become so diffused and combined in that visual space. Like if you could see, like an example of foreshortening is that more and more information is getting compressed, and that's what the floor looks like at that distance. The floor looks like this at this distance, and as you get farther away, if it's the same floor, it's still the same floor, but it's like the same thing. But like if you saw the spelling out of a word at a certain angle, but then as you got up, that thing just broke apart, but then as you got lower, it came back together. That's what's happening. Like, that's what reality does. We live in a simulation if you want to think about it that way. Right? So I'm going to have to create another page. What the hell time is it? Yeah. Maybe I'll take a break. Smoke break. This term refers to, and I'm going to hit my neighbor up for that, and let's see what she says. All right. So my next page is going to be just an open shot of explaining this is what foreshortening is. But I need to copy this whole thing before I unselect it. This term refers to how the floor presents the visual compression, presents the visual compression of information at every measurable distance, so that targets become so diffused and is it going to be? Become so diffused and combined in that visual space. This term refers to how the floor presents the visual compression of information at every measurable distance, so that targets become so diffused, so that targets become severely diffused and combined in that visual space. The next photo will exemplify that. This perspective. All right, and so then now what I need to do is I'm just going to make a different note for myself. Visual modeling. New paragraph. Create a program to invert the image when the scale reaches a programmed coordinate. I'm thinking along the lines of just being able to manipulate almost a mirage with PNGs. And I need a program to be able to do that with the mirage, with the image itself. So if I just have the image and the coordinates in the program are set to be a certain point, that when I move the image into that space, it starts to form an atmospheric phenomenon. Yeah, that was convoluted. So what happens when you're stoned? Alright, so I need to get rid of this. How do I get rid of this edge here? Like I want to... I guess I'm just going to have to do the same stupid thing again, right? Save as 1.5. And then I go to here and open this up. Right. Save. Okay. So now I need a new so let me go back and check something out here. Yeah, this is not conducive. This is way too small. Why is it, what? How did that happen? How can you save a document as a audio file? Alright, this is going to get washed out, I think. Unfortunately. I don't know how this got so... I'm just going to leave it this way. For right now, at least. Because this isn't going to be ready for publication. Maybe it could be done better, but I think this should be published. Well, that's not too bad. Okay. Alright. Alright. Good, 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 good. I'm happy. And let's do it again. Except I wonder if I can just program it to do... See, I can't change maintain aspect ratio. I want it to just be opening as a landscape. Okay. What's going on, Ryan S? Sorry, I'm not just just checking in. Okay, the difference between 11:04 and 11:15 is 11 minutes. 11:11. All right. So now, what am I going to choose for a different example? Right. I want to give a different example of this same idea. Let's see what else comes up in my Milwaukee experience. Okay, that's not it. That's not going to be it. This is a good one because it's, I think I could just probably use this. I'm trying to think if I want to go higher yet or if I'm going to just use this. Right? Because, yeah. Let's see. Keep looking. So what would be interesting is like if you zoomed in, if I would zoom in like this and then keep zooming. And I want to keep that guy. Oop, oop. All right. If I just keep zooming in like this, it's the opposite, so to speak. Like I'm fitting, what am I fitting? Too much? Like you couldn't be like, what is that? You know what that is? Can you tell me what this is? Can you imagine, how does this turn back into the guy coming on a bike, on a motorcycle? Save as a copy, right? And this is going to be, what are we going to call this? Minecraft World .1. Look how small it is. Why is it that small? So let me open this, I think, in Paint now. If I'm going to use this, I guess. Am I going to use this? Yeah, as a bicyclist. But where is that image now? Okay, so now if I bring this in, add it as a layer, it's a tiny, 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 look how small this is. Oh, that's because if I wanted to make it bigger. There we go. Right? Like this. Let's see. Right? Okay, so let's go with that. And we'll call this A. We'll call this A, and then we'll call this A prime, right? All right, so now we got to come back to this, change that back. Look at the, let's see. A prime in the photo is the area A prime in the photo is the focus at this point. Let's see. What am I trying to say? What am I trying to say? What was I saying in the previous one? What did I say? This term refers to how the floor. Oh, I'm doing foreshortening. So this is an example of foreshortening. But why am I doing this? How did I get sidetracked by this, man? Okay, I'm gonna undo this because I can't remember what I was doing, and I was trying to do with foreshortening. Okay. So what I'm going to say right now is this. What is that? What is this thing? Okay. Wow, that was weird. Alright. Text. This, having read my concept of foreshortening, this photo is the visual definition of the concept, right? Right? Okay. I mean, like, how am I'm trying to explain to everybody that what you're seeing here, what you are seeing here is the definition of foreshortening. What you are seeing here is the definition of foreshortening. As a result of the looming of the floor up to your focal point in the distance, the appearance of the floors being raised up and the visual space becoming less and less, those two things working together, that's visual compression. Oh man, what the fuck? Having read my concept on foreshortening, this photo is the visual definition of the concept. What you are seeing here is the definition of foreshortening. Things in targets in proximity appear differently than targets farther away. Targets in proximity appear differently than targets farther away. Those shadows are a good example shadow A in the foreground shows a sparse shadow of tree branches. Okay? Shadow A, I'm going to mark it, shows a sparse shadow of tree branches. Farther down, farther away are other sparse branches, but their shadows are darker because of the visual compression of that. Farther away are other sparse branches, but their shadows are darker because of the visual compression of that information at that viewer's information at that viewer's, maybe I'll say from that viewer's perspective. Okay. And then I can put an insert of the bicycle. You know, we can zoom in and show what's there farther down. What can you see at the... That's redundant. What can you see at the vanishing line? Okay, so now I'm going to do this, and now I want to crop it again, but I keep forgetting that I don't know how to do that. Unless I... Yes. How do I get... How do you get to crop to selection? I don't get it. Not here? Nope. Whatever. Alright, so now what I do is, I think... is bring this back in. Let's see. No, that's not what I want. No idea why I did that. Okay. What I'm trying to do is... I guess what I should do is zoom in. Like, I can see something right now, but I don't know what it is. So as soon as I can see what I think it is, right? Like, I don't know. That whole time, it was just like a white, you know, it could be a pedestrian, it could be someone on a bicycle, right? But I guess what I'm saying is, it's like from this point, I'm seeing, I would say, right here, I would probably say, I don't know, is it a person? Right? So what I want to do right now is just crop this part. I don't trust this part. I don't trust that thing. Cut. No. See, like, what did that... I don't know why I did that. What does that mean? Okay, you know what? I'm going to have to do it that way. Alright. This is why I have, like, you know, 5 different... What the heck? Oh my gosh. Why did all of that happen? Okay, no, I don't know where we're at right now. Yeah, so... Okay, I gotta get rid of this. Okay, just do that. Okay. This needs saved. Okay. Don't come here. Open this. And do this. No, is that what I wanted to do? No. This is what I want to do. I need to get the original. And crop that. Zoom in on this one. Right? Like, I can see something right here, and it's like, this is a path, right? This is what, like, inductive deduction is, right? You're looking, this is a walking path, walking path, walking path. I'm walking, oh, that must be another pedestrian. But that's zoomed in. You know what I mean? Like, I can't really see anything, you know, particularly, but whatever. You get it? So... Alright, so what I want to do right now is... Can I edit that size? Or do I have to do it a different way? I think I have to do it this way. Like, I still can't see anything, really. Maybe I'll stop right there. .6B. Alright, so now I go here, and then here. Alright, and now that is now here. And even I can, you know, even distort this one a little bit. Alright, I've been streaming long enough. We'll see what's going on here.
Oh, great. Brenda debates.
I'm not getting caught up in this drama.
All right, I'm going to wrap this up right now. So thanks so much for watching this new and exciting adventure of The Plain Truth. I've been your host,